Welcome. Today, I'm excited to introduce a groundbreaking project that we're undertaking in collaboration with the Apparel Impact Institute as part of their Climate Solutions portfolio. At Pozzi Leopoldo, with over a century of history in the textile industry, we've always strived to push the boundaries of innovation, particularly in the area of energy efficiency. Now, as part of AII's ambitious efforts to combat climate change, we're proud to present a solution that addresses one of the most energy-intensive stages in textile production: wet processing. Our project focuses on implementing the RHeX+ heat pump system, a state-of-the-art heat recovery solution designed to drastically reduce energy consumption and greenhouse gas emissions. Over the next few minutes, I'll walk you through how this collaboration is not just a step forward for Pozzi, but a leap towards a more sustainable future for the entire textile industry. But first, let me take a moment to introduce you to Pozzi Leopoldo, a company with nearly 140 years of history rooted in the heart of Lombardy, northern Italy. Founded in 1885, our company has been at the forefront of manufacturing advanced machinery, mainly for the textile industry, specializing in wet processing equipment. Over the years, we've built a reputation for industry leadership and innovation. Our deep expertise has allowed us to stay ahead of the curve, particularly in the realm of energy efficiency. For the past 30 years, we've been dedicated to developing solutions that not only enhance factory performance, but also reduce environmental impact. Our commitment to sustainability is evident in our innovations like the RCR and RHeX heat exchangers, which have set new standards in energy recovery. Pozzi's contributions have not gone unnoticed. Our solutions have been recognized by many organizations, such as the Solar Impulse Foundation, as one of the top 1,000 solutions for protecting the environment in a profitable way. Additionally, we've participated in 2 Horizon projects supported by the European Union's Research and Innovation Program and have been selected by the European Commission as key innovators featured on their Innovation Radar, which highlights high-potential innovations in Europe. With numerous patents to our name and these prestigious recognitions, Pozzi Leopoldo continues to be a driving force in advancing factory efficiency and supporting the industry's shift towards more sustainable practices in textile and beyond. Our RHeX solution has already proven its effectiveness across various industrial environments, including textiles, where it's been instrumental in reducing energy consumption and emissions. Now, with the integration of a heat pump, we're able to take this even further. Not only do we recover more energy, but we also reduce the reliance on thermal energy, which typically comes from fossil fuels, by converting a portion of it to electrical energy, potentially from green sources. Textile wet processing is a highly energy-intensive process due to its heavy reliance on hot water, making it a significant contributor to CO2 emissions. Unfortunately, much of this energy is lost as hot water is discharged, still carrying valuable thermal energy but also heavily polluted. Traditional heat exchangers often fail to recover this energy efficiently because they struggle with the dirty, polluted water typical in these scenarios. This is where our RHeX+ heat pump system stands out. It's specifically designed to handle these difficult conditions, allowing us to recover and reuse that energy, reducing both the environmental footprint and the operational costs of the mills. We'll explore the technical details of how this system works in the next slides, but it's important to recognize that by addressing these challenges, we're not only making processes more efficient, but also contributing to a reduction in CO2 emissions, something that benefits all of us. Climate Solution Portfolio's funding is crucial for scaling our innovative RHeX+ heat pump system, making it accessible to mills globally, especially in developing regions. This funding allows us to improve existing practices within mills, helping them reduce greenhouse gas emissions as they transition to cleaner sources of thermal energy. It also helps us connect with new technology partners worldwide and enhance our existing networks, including heat pump manufacturers. Through this support, we can also find new maintenance and support partners and increase visibility for the solution both within the industry and beyond. Our solution is designed to focus on energy efficiency and emissions reduction, key elements for meeting global sustainability goals. We aim to lower the carbon footprint through the use of cleaner energy sources, reducing expenses for the mills, as well as improving both the efficiency of the process itself, as well as annexed ones such as effluent treatment. Pozzi is spearheading a feasibility study to evaluate and demonstrate the benefits of the RHeX+ heat pump system, a state-of-the-art heat recovery solution designed for the fashion industry's hot-wet processes. Traditional heat exchangers often struggle with clogging and efficiency loss. However, the RHeX+ heat pump system overcomes these challenges, ensuring high efficiency and enhanced energy recovery through the integration of a heat pump. The first main issue is that mill discharges are polluted, both mechanically and chemically, which causes traditional exchangers to clog. Pozzi's RHeX is the only existing and patented exchanger designed specifically to handle these dirty and troublesome fluids, recovering heat efficiently from these sources. The second main issue is that any heat exchanger can only recover energy up to the temperature limit of the source. But by integrating heat pumps with heat exchangers, we can both increase the amount of recovered energy and improve the overall efficiency of the system. This ensures that mills can operate more sustainably while recovering more energy. Let's break down how the RHeX and heat pump system works. First, the clean water needed for the process is preheated using a heat exchanger that recovers heat from hot discharges. Next, a second heat exchanger captures additional heat from warm wastewater. This can be from the same stream or a different one, with lower temperatures still providing valuable thermal energy. Now, the heat pump comes into play. It converts the recovered thermal energy from the evaporator side, at a low temperature, into a higher temperature using electrical energy with very high efficiency, as it's playing with state change and latent heat instead of direct thermal heat transfer. This step allows us to raise the temperature of the energy and make it useful for the process. The heat pump then transfers this energy to the clean water via the condenser, and the heated water is fed back into the process. What's great about this system is that it can recover nearly all the thermal energy needed, while using only a small amount of electrical energy, potentially from sustainable sources. This makes the RHeX and heat pump system a truly green solution, helping mills operate more efficiently while significantly reducing their carbon footprint. By harnessing energy that would otherwise be wasted, we're supporting a more sustainable, environmentally friendly approach to industrial processes. This grant is instrumental in advancing our RHeX and heat pump system with three key objectives that are crucial for the project's success. First, we aim to validate and demonstrate the system's effectiveness by conducting feasibility studies across 15 mills worldwide. By doing so, we will assess its adaptability and performance in diverse environments, ensuring its broad applicability. Our second objective is to help these mills reduce energy consumption through the implementation of the system, ultimately lowering their operational costs and increasing their efficiency. This step is essential in achieving both financial and environmental benefits as each mill transitions to a more sustainable energy model. The third objective is to cut CO2 emissions, contributing to the global effort of reducing greenhouse gases by shifting to lower carbon thermal energy sources. This aligns with industry-wide goals for sustainability and environmental responsibility. To achieve these outcomes, the grant will be utilized for site assessments, detailed engineering designs, and post-implementation monitoring to track performance, ensuring the system delivers on its promise. Each step is designed to maximize the impact of the solution, ensuring both short-term and long-term benefits for the mills. The intended outcomes with this project is to achieve substantial energy and cost savings across participating mills, with a targeted energy reduction of up to 70% in their processes. From an environmental perspective, we aim to make a significant impact by reducing CO2 emissions by thousands of tons annually as we transition these mills to cleaner sources of thermal energy. Beyond energy and environmental gains, we are also focused on process optimization, helping improve the overall efficiency of production within each mill. We already have 2 plants that have successfully integrated this solution, and the results are impressive. The mill shown here is a cotton yarn dyer in northern Italy, which is preheating its water using only electrical energy with a coefficient of performance of 11.5. This means that for every 11.5 kilowatts of thermal energy, they're only using 1 kilowatt of electrical energy. This kind of efficiency isn't just a cost-saving measure. It's a sustainable solution that reduces reliance on fossil fuels, promoting a cleaner and greener future for industrial processes. By harnessing energy more efficiently, we are helping to drive the textile industry toward more sustainable and eco-friendly operations. Once again, this is an initial study on only 15 mills, so the total reduction potential from this solution, if we only consider these mills, is limited to about 20,000 tons of CO2 reduction per year. However, the savings per site are highly dependent on the region and the nature of the plant, whether it's related to production volumes or the type of fuel currently used. As a reference, we've used the same sample working site in Italy mentioned earlier for our calculations and scaled based on different geographic factors, such as average production volumes, working hours, and fuels used in different regions. Looking at the bigger picture, the success of this initial study could translate into a reduction of over 400,000 tons of CO2 equivalent by 2030. This highlights the significant potential for scaling this solution beyond the initial sites. As we move forward, we aim to draw key learnings from this project that will guide our broader strategy. First, we hope to demonstrate the adaptability of the RHeX and heat pump system across diverse conditions, from different environments to a range of production types. This will help us understand the system's efficiency even in fully developed mills, where we might encounter unexpected barriers or variables. Second, we aim to increase the visibility of our solution, positioning RHeX and heat pump as the go-to solution for energy efficiency and sustainability in wet processes. By reducing greenhouse gas emissions and lowering operational costs for mills, we hope to set new standards in the industry, helping mills move toward carbon neutrality in a sustainable and profitable way. These anticipated learnings aren't just technical achievements. They represent a broader impact that we plan to have on the entire industry, driving a shift toward more sustainable and cost-effective production practices. As we look toward the future, our scaling strategy focuses on broadening the reach of the RHeX and heat pump system globally. Our target is to achieve 300 installations by 2030, building on the success of our initial implementations. By leveraging these case studies, we can showcase the real-world benefits and impact of the system, encouraging more mills to adopt this sustainable solution. A key component of our strategy will be developing strong partnerships with technology providers, mills, and other stakeholders. These collaborations will be essential in ensuring the seamless adoption and integration of the system in diverse environments, paving the way for global expansion. In terms of our contribution to the 2030 climate goals, our solution will play a vital role in helping the textile industry move closer to carbon neutrality. We aim to foster more sustainable practices within the sector by promoting technologies that reduce reliance on fossil fuels and shift toward electrification. But the benefits don't stop there. Beyond the environmental gains, the RHeX and heat pump system offers significant energy savings, which translates into cost reductions for mills, improving both their financial performance and their sustainability footprint. By embracing this technology, the textile industry can not only cut greenhouse gas emissions, but also enhance process efficiency and operational resilience. In conclusion, our project presents a unique opportunity to support both the environment and the economy. It's about fostering a future where sustainability and profitability go hand in hand, making a meaningful impact in the global effort to address climate change while driving growth and innovation within the industry. Thank you for joining us on this journey to explore how the RHeX and heat pump system is aiming at transforming the textile industry. If you'd like to learn more about our solutions or stay updated on our progress, we encourage you to visit our website and follow us on LinkedIn. There you'll find the latest updates, case studies, and insights on how we're driving sustainability and innovation forward. We look forward to connecting with you as we continue to make a lasting impact on the industry and the environment.